We're going to be starting page 46 of Force in Motion. On this page, we are going to be asking the question, what is Newton's second law of motion? Which is harder to push, a full shopping cart or an empty one? Who can cause a greater acceleration on a shopping cart, a small child or a grown adult? Changes in force and mass. Suppose you increase the force on a cart without changing its mass. The acceleration of the cart will also increase. Your cart will also accelerate faster if something falls out. This reduces the mass, right? Kind of like the weight. This reduces the mass of the cart, and you keep pushing just as hard. The acceleration of the sled in Figure 2 will change depending on the mass of the people on it and the force the sled dogs apply. Newton realized these relationships and found a way to represent them mathematically. Determining acceleration. Here's our key point now. Newton's second law of motion states that an object's acceleration depends on its mass and on the net force acting on it. This relationship can be written as follows. Acceleration equals net force divided by mass. So acceleration, how much your velocity is changing, can be described as the total force acting on that object divided by the mass of that object. This formula can be rearranged to show how much force must be applied to an object to get it to accelerate at a certain rate. So we can take all of this and we can move mass to the other side by changing it into a multiplication problem instead of a division problem. So now net force, the total force you need to apply to an object, is equal to its mass times its acceleration. Figure 2, Newton's second law. Suppose that 4 dogs pull a sled carrying 2 people. We'll go over this in our questions section. Let's move to page 47. Acceleration is measured in meters per second, or m divided by s squared, meters per second squared. Mass is measured in kilograms, kg. Newton's second law shows that force is measured in kilograms times meters per second, or kilograms times meters per second squared. This unit is also called the Newton, N, which is the SI unit of force. 1 Newton is the force required to give a 1 kilogram mass and acceleration of 1 meter per second squared. All we have are questions left on these pages, so you can stop the video now and go to the question section.